here we go with lab number 4, properties of matter and separation of mixtures. So here's our first setup for part A. We're going to learn gravity filtration. So I've got my 60-degree funnel, and it is currently supported by a ring holding it in place up out of the beaker that's going to be my catch beaker by a nice little ring stand. So now we are going to fold up our filter paper. So here's my piece of filter paper. I've already went and taken the mass of the dry filter paper, and it was 1.1442 grams, this filter paper. So to get this filter paper to fit my funnel nicely, what I'm first going to do is I'm going to fold my filter paper directly in half. The box of the filter paper, get that out of my way. So I'm going to fold my filter paper in half, fold the circle directly in half, like that. And then I'm going to fold that circle in half again. And now I've got a quarter of a circle like that. And to put it in your ring stand, what you're going to do is, so now you've got two little pockets in here, right? You've got two little pockety areas. And that's what you're going to put in your funnel. So you're going to open it up like that. Or if you go in between, you've got two little pockety areas. So I'm going to place that in my funnel and see what happens. It kind of pops out, right? It doesn't really stay in there well. That's not going to work for us great. So what I'm going to do is I'm going to take my wash bottle with deionized water, and I'm just going to kind of dampen my filter paper, get it wet, and I'll make it stay in place. All right, so our first task is to observe some gravity filtration. So this method here that we have set up is gravity filtration. We're going to use the force of gravity to pull the liquid through our solid and catch it in the beaker below. So here we go. We've got our filter paper properly folded, put and set into place with a little bit of water. And I have a mass of sand that I've weighed out. It says about 3 grams. The exact mass. I've taken the exact mass of this bit of sand. It is 3.0584 grams. So now I'm going to add some water to the beaker so I can filter the sand from the water. So here's my sand. Gorgeous little sand. Sure would be nice to be at the beach. All right, so I put a little bit of water and my sand, and now I'm going to go ahead and pour that into the filter. So the sand is totally sticking to my beaker, so I'm going to add more water to make sure I'm rinsing out my entire sample so I can get all of it filtered through. So we're going to go ahead and keep rinsing. The less water you could put into this gravity filter, the better, because it's going to take a minute to drip through there. So now I've got all my sand inside of my beaker. I've got a nice clean beaker. And now we get to watch it drip, 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 drip through until it's all separated out. Show you. Watch the water level slowly go down. go. It's looking pretty good. It stopped dripping. More water coming out. Oops, there's one little drop hanging on. So most of it's kind of gone through. Put this back up here. All right, so most of it is dripped through. Just gonna go ahead, take the paper out, and so you can make some observations about this. So let's take a look at that. Fold out, let you look at it. The way paper is definitely totally soaked, and you can see the sand is still pretty wet. I'm gonna go ahead and take the mass of this for you guys, and I'll report it in the data. All right, here we are for part B of Lab 4, finding physical properties of unknown substances A, B, and C. So our goal here is to make observations about unknown A, B, and C because we're going to get a mixture of all three unknowns put together, and your goal is to separate those from one another by the properties that you're going to discover for part B. So here, just so you know what it looks like, here is a sample of the unknown mixture. It's got some big chunks in there. It's kind of grayish colored. There's smaller pieces. If you look a little closer, where's the camera? Focus in. You can kind of see there's finer pieces in there. So there's big pieces. There's white. There's almost like a sandy looking stuff in there. And there's like dark flecks. I'm just helping you make some observations on that. All right, so that is our unknown sample that we're going to try to separate out. So we've got unknowns A, B, and C, and we're going to determine their solubility in water and acetone and their magnetic properties. I'm actually going to skip the flammability and tendency to melt because you're not going to use that in your separation. So here we are here with unknown A, a little sample of unknown A so you can kind of check it out. It's kind of bigger chunks. White crystalline chunks of a solid in there. Unknown B as another white solid, much finer crystals. There's a couple big clumps of it in there, but it's just a bunch of little white crystals stuck together, kind of looking like salt or sugar kind of texture. And here is unknown C. Unknown C is a fine black powder. It's hard to see on camera, but there's some shinier flecks in it as well. So there's our unknown C. All right, let's get to the solubility. So to test the solubility, we're going to place a small amount, about the size of an unpopped kernel. Have those ready. And add the desired solvent. So I put in here, I've got unknown A, I've got 2 samples of unknown A, 2 samples of unknown B, 2 samples of unknown C, 1 for water, and 1 side for acetone. Acetone is another polar solvent, also known as a universal solvent. Takes your nail polish off quite nicely. All right, so we're gonna add the desired amount of the solid to the sample dropwise and see if it's soluble. So we're going to consider it soluble if it dissolves. If a volume of 100 drops is insufficient to dissolve a solid, then we're going to consider it insoluble in that solvent. All right, so here we go. This is our first sample of unknown A into the test tube to test for solubility. So I'm going to go ahead and put in 10 drops and agitate the solution. That's close enough, 10 drops. I'm going to agitate it by flicking the bottom of the test tube. So definitely got chunks still floating around in there. Doesn't seem to be dissolving, so I'm gonna go ahead and add another aliquot, or a small portion of my solvent, which is water. I don't know if I mentioned that. I'm adding water to this first one. For unknown A, a little bit more. I'm gonna agitate the solution. Clicking the test tube. Definitely still have my solvent, my solute is not dissolving. I've got chunks in there. We'll add another aliquot of water. All right, still not dissolving. We'll do it one more time. And we should be up to roughly 100 milliliters, maybe. Agitation. These chunks don't want to move around anymore, but they're sure not going anywhere. You see some smaller chunks being agitated and moving around in the water. But the big chunks are just settled on the bottom and not dissolving. Okay, so I'm gonna say that unknown A is not soluble in water. Put that back in my test tube rack. Okay, let's get the water out of here. Let's pull in the acetone. So we've got acetone. And I've pulled a little portion out. Ooh, I can smell that nail polish. It smells just like nail polish remover. Oh, it is the base nail polish remover. Whew. Okay, and I don't need to smell it directly. I can smell it by wafting it. Otherwise it's way too strong. So acetone, I labeled my beaker with acetone, so I know that's what it is. I'm gonna use my little plastic pipette to put portions into unknown A. So now I'm gonna go ahead and add acetone to unknown A. Oops, it's on the counter. Sorry, it'll dry up quickly. I'll go ahead and agitate the solution. Ooh, see that? There's some chunks in there still, but definitely way, ooh, I think. Oh no, there's a couple little chunks in there. Oh, it's hard to see. The sunlight coming in the windows is not my friend today. All right, there's one little chunk left in there, but most of it's dissolved. So let's put just a little bit more acetone in there. Now, you can see I'm not being very careful with how much, with my samples that I put in to the test tubes, or how much of my solute I'm putting in there, or my solvent I'm putting in there. This is just qualitative, it is not quantitative. We're just making observations, not any measurements on this. So that last little bit of acetone readily dissolved unknown A. So unknown A is definitely soluble in acetone. All right, let's try unknown B. All right, here's unknown B. I'm gonna go ahead and add a little bit of water and decide if it is soluble. Just a little bit. And agitate the solution. You can see, you guys see that? Unknown B is starting to dissolve. Dissolve in the solution. I don't see the chunks on the bottom anymore. The solid's going away. I'm gonna add just a little bit more water. Let's see if I can get it to get fully dissolved. All right, unknown B, very little bit of water. Unknown B is gone. It is dissolved in water. So unknown B is soluble in water. Now let's take unknown B, and I'm going to add some acetone. My solution turned very cloudy. But I can definitely see unknown B still settled on the bottom of my test tube. Definitely not completely dissolving, even though it's become cloudy and cool to the touch. Let's add a little more acetone. We got a layer on the bottom still. Unknown B in test tube. And when I agitate the solution, I can see unknown B settling back down to the bottom. Let's give it another shot. All right, unknown B is not dissolving in acetone. So unknown B is not soluble in acetone. All right, let's try unknown C. So first up with the water. Try to rinse some in test tube while I add the water. All right. Got murkiness here. Hard to tell, especially on camera. It looks murky, right? We've got a murky looking water, but when I tip the test tube, I can see that it's definitely gonna be hard to see on camera. But there's definitely a layer of unknown C on the bottom. So some of the particles I think are suspended, but not dissolving. Let's add some more water and see what happens. Agitate the solution. Oh, so the water itself has like a muddy appearance and a sheen on the top of that meniscus, but there's definitely sediment in the bottom of my test tube. It does not appear to be dissolving. Let's add a little bit more. All right, so the more water I add, the more clear it gets that it's not dissolving completely. Okay, I don't know if you guys can kind of see that layer now, how it's light brown and then there's this dark at the bottom. There's sediment at the bottom. Unknown C does not appear to be soluble in water. Okay, all right, unknown C is not soluble in water. Let's try unknown C in acetone. Oops, that was a lot of acetone. Agitate the solution and mix it up. Give it a chance to dissolve if it's going to. Seems like the same thing is happening. It's murky. Not mercury. This is not mercury at all. It's murky. It's murky. It's hard to tell, but it looks like there's sediment forming on the bottom. I'm going to add a little more acetone. See what that does. I'll even rinse it off the walls of the test tube. Again, super hard to see on camera because it's so dark. But we've got a layer of sediment at the bottom and a murky, I can't stop saying mercury, a murky layer. Muddy looking layer, maybe that'll help. Just change my word. All right. One more drop, or one more aliquot, small portion. Acetone into my test tube. Alright, I'm going to let this sit for a few minutes before I make my final determination. It doesn't appear to be soluble, but I'm going to let it sit and see what happens. Okay, let's move that out of the way. Can I clean up my little bit of mess that you? Gotta keep a nice, clean, neat work surface. When you guys get to actually go do labs, that's super important to keep everything neat and organized on your bench top. It'll just make your life go so much smoother if you have it laid out nicely and you're not getting confused. All right, so we did our solubilities in water and acetone. Let's do magnetic properties. So for our magnetic properties, we're going to we'll put small amounts of our solids onto some filter paper. And make our observations. 3 pieces of filter paper. About a magnet. And there's A, B, and C. So I'm going to go ahead and drop some unknown A. I'm going to do it through filter paper because I don't want my unknown to actually stick to the magnet where I can't get to it. Or get it off easily if I were to need to. Okay. Little bits of A, B, and C I'll put out and made a mess. See, so much for that clean bench top I said. All right, so, this is super easy to see, right? You guys can totally see unknown A on that white filter paper. Not at all. Well, there's not much to see. I'm swirling the magnet underneath the filter paper, and it's not doing anything except for spilling under the bench top when I pick it up and make a mess. Might have not been the best. All right, so unknown B, also super hard to see. Moving the magnet, not doing a whole lot of anything. Let's see, unknown C might be a little bit more entertaining. There we go. Unknown C is way more entertaining and definitely affected by the magnet. You can see all those. See whatever it is lining up with the magnetic field produced by the presence of the magnet along the field lines. It's kind of fun. Definitely like dirty. Make my filter paper all brown. All right. So unknowns A and B are not responsive to the magnet, but unknown C most certainly is. Let's see. I'm either going to accomplish what I want to accomplish or make a giant mess. Let's see which one we're going to do. Hold on to the magnet. Ooh, look at that. I accomplished it. Totally was worried that it was just going to fall off all over the place and make a big mess. All right. So that is unknown C. Let's check our unknown C in water, or acetone again. So I let it settle for a little bit, and we can see that this kind of cleared out, and unknown C settled at the bottom in acetone. So unknown C is neither soluble in water or acetone. All right, that is the end of part B. All right, guys, here we are to the last part where we're gonna actually separate the mixture. So I've got my unknown sample, which is a mixture of all three of our unknowns. We've determined their solubility and their properties. So we're gonna use those to be able to separate our mixture. So here is my sample of my unknown. I've gone ahead and taken the exact mass of that unknown, right? It tells us to get about 3 grams of the unknown, I think. And then we're gonna separate that out. My exact mass, as noted in the data tables, is 2.7472 grams. So the route I'm gonna take in separating the mixture is I'm going to use the magnet to first separate out unknown C. And then because of the solubility of unknown B compared to the solubility of unknown A, I'm going to use water to dissolve away unknown B and rinse it through my funnel. I'm going to fill and leave with just unknown A. So we'll have unknown B in water at the end of it. Unknown A will be sitting on top, and unknown C will be in a separate beaker all by its lonesome, so we can get a mass of all 3 components. All right, so here we go. I'm gonna pour my unknown out onto the filter paper. This specifically asks us not to get the unknown onto the magnet. So there's my unknown and my magnet. Let me just double check you can see me. There we go. My magnet. So let's see. I'm just moving the magnet around on the underside of the filter paper, trying to get the iron filings to get out of the other solids and kind of separated. So I'm going to dump the other solids into a different beaker for now. Hope that I hold on to most of my iron filings. Ooh, there we go. Getting rid of those unknowns A and B. Hopefully holding on to unknown C. Turning this filter paper slowly. Get rid of all that unknown there. All right, I think I've got a pretty good portion of that unknown off there. I've just got my unknown C stuck on my magnet. I'm gonna go ahead and put unknown C back in the original beaker, keep it separated. And what I think I'm gonna do, because I'm sure that I lost some of those tiny little bits of unknown C, I'm gonna do that one more time and see if I can pull any more unknown C out of that mixture. Move the mixture around, see if I can get any more of the unknown. Oh, I can see some little flecks of the black in there. I don't know if you guys can see it. I'll try to show you. Got the little flecks of the black still moving around in there for unknown C. Go ahead and pour that off. Oh yeah, look at that. Totally still had some in there. Not a ton, but we had some. All right, go ahead and pour that in there. So I've got unknown C separated out. I will go ahead and weigh that and report that mass in my data tables. All right, so now I've got just A and B. So I've successfully pulled out C. I've got A and B left together. So what I've decided to do is I'm gonna go ahead and dissolve them in water. And then, so unknown B should completely dissolve in the water and go away, leaving unknown A behind. And then I'm gonna filter unknown A and it'll be left at the top of my filter. So this is not the filter setup you saw earlier in the video. That was gravity filtration, and I'm gonna switch it up and switch to vacuum filtration for the sake of all of our sanities and speed. So the vacuum filtration will actually use air to suck, we'll use a vacuum to suck air through this funnel and will help pull my solvent through to catch it down here in the bottom of this flask, which will greatly speed up this task for us. So I'm gonna add some water. I'm gonna add plenty of water, deionized water, to go ahead and dissolve that. So I'm gonna swirl it around. Dissolve it. Let's see. Well, it looks like I've still got some of those smaller particles in there, so I'm not sure that it's all dissolved. I'm going to add a little bit more water. Make sure it's all in. I don't want to go too much because I don't want it to overwhelm my catch flask here. But I do want to make sure Unknown B is thoroughly dissolved. Okay. All right, we're looking good. So I'm gonna go ahead and turn this on. You might have trouble hearing me, so I'm gonna go ahead and tell you what I'm gonna do real quick before I start doing it. When I flip this switch, oh, I guess it's not all that noisy. It's causing the vacuum to go through here, and it's pulling air down through this funnel, which I can show you the little pieces in a little bit. And I've got a piece of filter paper in it. And just like with our other filter, where we put a little bit of water to make that filter paper stick to our funnel, I'm gonna do the same thing once I turn the air on, or turn the vacuum on. I'm gonna do that. Can you see me? See if I move you over just a little bit, so you can see it better, hopefully. That is really washed out. Okay, so then that sucked the filter paper down, so we're gonna prevent any of our mixture from going underneath the filter paper and straight through the filter, or the flask, the funnel, into our catch. So I'm gonna swirl it. So I wanna swirl this. That helps keep my particles suspended in the solution, so I'm not adding a whole bunch of extra solvent to pull it through. Go ahead and start pouring it in. Swirling as I go along. Leaving my solids behind. Ooh, I got lots of it still stuck in here. So now I'm gonna go ahead and rinse that down. I wanna make sure I get all of those pieces in there so I can go ahead and dry it out and weigh it to measure this Unknown. Come on, get out of there. Sticking. There we go. And you can see how quickly that's filtering the water through, pulling that solvent through. We've been here for ages with gravity filtration. It just didn't sound like fun to me, so I figured we'd step up the process here a little bit. So, whoop. Oh, I still got some chunks hanging out on the bottom. I'm gonna keep spraying my water, swirling till I get all of it through, because it's quantitative and we're trying to get the most accurate results possible. There we go. All right, that looks pretty good. Had a pretty good separation going there. So I now have successfully pulled Unknowns A, B, and C apart from one another. So I'm gonna give you masses for Unknown A. Off camera, I'm gonna let it dry for a little bit, just make sure all of our water is dried out of there and not adding mass to that portion of our Unknown. You will get a mass of Unknown C. And I think we're gonna throw Unknown B on a hot plate in a tiered beaker so we could get rid of all the water and have Unknown B left over in our beaker. All right, we're gonna go ahead and pause the video here for a little bit and pick up with the boiling of the water.